Hi, my name's Angela Dyson. I'm at Newcastle University in the School of Maths, Stats and Physics, and I'm going to talk to you about what we did for first year remote labs this year. I thought I'd start by explaining what we used to do. Our first year labs were very traditional, arranged around 2 semesters between the Christmas break. In the first semester, the first 5 weeks were given over to the teaching of MATLAB. This was done with a 2-hour in-person practical and then a 1-hour lecture. The remaining 5 weeks of the semester were in the teaching lab with scripted experiments on known physics, and these were completed in a 3-hour session every week. Following the Christmas break, the students again did scripted experiments, but this time on physics from the first year, and each experiment took 2 of the 3-hour sessions. The typical class size is about 80 students, supported by 3 academic staff and 6 PGR helpers. The students usually work in pairs. In addition to the sessions listed, we usually also run drop-ins or additional sessions in the run-up to assessment deadlines. The lab is assessed in the following way: MATLAB by a computer-based assessment with numbers, the lab through traditional lab books which the students hand in at the end of every week or fortnight and are marked and returned to them. They do 3 reports, with the first one being formative in nature, a low-stakes assignment to give them some feedback and experience of writing a report without the pressure of a large weighting on the module. The feedback is always timed for the students to feed forward to the next report, and for the reports, the expectations, the format and the marking scheme are all vertically integrated across the programme. So when we realised that we needed to run remote labs, we got the team together and thought about what lab was actually for. It gave us a chance to really drill down and think about what the key things were that we wanted students to take away from labs. So in our discussions, we thought about the learning outcomes for the module and the programme. We thought about what skills the students would need to take into second year lab the following year. We considered the background of the students and also gave some thought to the pressures that they were likely to be under in this year with all remote classes, and so essentially a flipped setup. So what we decided is that we wanted the students to be able to plot and analyse data, appreciate uncertainties from different sources and combine them, gain some practical hands-on experience and skills, develop their report writing, and above all, have some fun, hopefully. So this was what we came up with and what we delivered, although initially we thought the semester 2 work would be in-person, socially distanced. In the end, that wasn't, and Newcastle didn't deliver any in-person sessions last year. The university decided to shorten the semesters to 8 weeks each, so things changed slightly over the previous year. The first 4 weeks were given over to MATLAB, this time with a 2-hour synchronous lab and a 1-hour asynchronous lecture. The remaining 4 weeks were given over to data analysis and uncertainty skills building, where the students built up a portfolio. This was supported by 2 1.5-hour synchronous sessions and the virtual learning environment discussion board. Following the Christmas break, we did a session to consolidate the data analysis and uncertainties that the students had learned before Christmas in preparation for a computer-based assessment that was done the following week. Then we moved on to the structured build and test workshops. These were supported again by 2 1.5-hour synchronous sessions and the VLE discussion board. The final 2 weeks were given over to an open-ended experiment designed by the student themselves again supported by the 2 synchronous remote sessions, but this time with direct contact with their PGR helper or staff member. MATLAB was assessed in the same way. The first part of the lab before Christmas was assessed by a portfolio that the students built up over the 4 weeks and supported by a chance to get formative feedback. After Christmas, the data analysis and uncertainties test happened through numbers, and then the students did 2 reports. We added additional synchronous remote sessions prior to the assessments again and did a whole one before the first report deadline was due. Another session was given over to the students discussing ideas for their own experiment with their peers and with their PGR helper. You can see on the right an example of the calibration spectra from the spectrometer that the students built. So this is what we delivered in semester 2. The students had been provided with a tablet by the school, and each week we delivered remote sessions on Zoom using breakout rooms. The students had been divided into 8 groups of 10, and they remained in these throughout the year with the same PGR helper. The students built a cardboard spectrometer. They had an app which they installed on their tablet. They built a calibration circuit and tested their spectrometer. And then they built an LED circuit, which you can see here on the right with the breadboard. And then the final 2 weeks, the students designed and executed their own experiment. We were very pleased with the range of experiments that the students did on their own. For example, spectra of military-grade glow sticks, the efficacy of emergency lighting for colourblind people, and a comparison of incandescent and LED traffic lights. Something that we didn't think about was that students hadn't really encountered calibration before, so we had to quickly do an extra session to cover that. Overall, the module scores were very consistent with the previous year, the average to within 0.5% or so, and engagement, as measured by attendance at the sessions and submission of work, was better than in previous years. The students seemed to really enjoy the small working groups, and some of them had their own WhatsApp or Slack channels set up. We did manage to get a little bit of feedback from the students. Some, of course, were not happy with take-home experiments and would have preferred to have been in the lab. Some felt that we didn't give enough support for the report writing. Others gave contradictory feedback and said that the assessment really helped. Overall, students seemed impressed by what we tried to do and were really pleased that they'd managed to build a successful spectrometer.